Once you have a machine with Ubuntu 24, we can proceed with the installation of ROS2. During this course, you can decide which version of ROS2 to use, depending on the Ubuntu version that you have installed. If you are using Ubuntu 22, then you will need to install the version Humble of ROS2. Otherwise, if you are using Ubuntu 24, like in this case, you will need to install ROS2 Jazzy. The code that we are going to develop during this course is compatible with both of these ROS2 versions. In this lesson, as I am on Ubuntu 24, I'm going to install the version Jazzy of ROS2, and you can find all the commands that I'm going to use in this lesson also in the resources of this lesson as a PDF. To start the installation process, let's open here the ROS2 Jazzy installation page. So actually this one here that you can simply find also in the resources of this lesson. And now we can simply copy paste all of these commands here. So all of these commands that you can find here. So let's open a new terminal. Let's put this one on one side and let's start with the first one. So actually this one is only used in order to check the current local, so we can avoid using it. And we can start with the second command. So let's press enter. And we need to do the same for all the other commands. So let's take also this one and let's paste it. Let's take this one here as well. And finally, let's also take this one here. Perfect. So with this one, we have set the local. Now let's move on to the next chapter. So the enable required repositories. So let's start by copying the first command and let's paste it. The second command. Perfect. Let's press enter as well. Now we need to install this package here. So we need to update the system and we need to install curl. And we're going to use this package here, so curl, in order to download this key here. So let's paste it. Perfect. Now we can also copy this command here and let's paste it in our terminal. And now finally, we are to the real installation part. So let's start by installing this one here. So the ROS developer tools that we're going to use in this course. So let's take the ROS developer tools. Let's type the Y. And now once we have the ROS developer tools, we can move on to the actual installation of all the ROS2 components. So first, let's update our system and let's also upgrade it. Perfect. And then we can finally install here the ROS Jazzy desktop version. So this one here, that as you can see here, is the recommended one, as it already includes some visualization tools, like for example RVs. It also contains demos, tutorials, and as you will see, a lot of useful packages. So let's copy and let's paste it here. So let's type again the letter Y and let's press enter. Now this command is going to take a while as our system now is downloading almost 1.5 GB of data. So let's wait for the installation of ROS2. Once the installation of ROS2 is finished, we can move on to the final part. So this one here, that is the setup of the environment. So actually we need to insert this line here, that is the source of the Jazzy installation, so of the ROS2 Jazzy version that we have installed on our system. And we need to insert this one, so we need to insert this line here within our bash rc file. So if you can see here, there is a bash rc file, so this one here that is automatically available in your home folder. And so now we can modify this file here, and for example we can use nano to access the bash rc file. So let's modify this file, and actually we need to go at the end of this file here, and we simply need to paste this command here, so the source of the ROS Jazzy installation. Now let's press Ctrl O to write the file, so let's press enter. So now we have saved this file, and with Ctrl X we can exit. Perfect. So now that we have sourced our ROS Jazzy installation, if we open a new terminal, we already can use the command ROS2. And so for example, let's use for this very short demo the command help. So let's press enter, and actually this command just confirms us that ROS2 is properly installed in our system. So actually we can see that we have no errors, and actually here the ROS2 help command provided us with a very long list of all the commands that we can use with their description. And don't worry if you don't know this command yet, or if you don't understand what they are used for. We're going to use many of them in the course. If you decided to install Ubuntu 22 on your PC, we can proceed to the installation of the version Humble of ROS2. During this course, in fact, you can decide which version of ROS2 to use, depending on the Ubuntu version. If you are using Ubuntu 22, then you need to install the version that is called Humble of ROS2. Otherwise, if you prefer using Ubuntu 24, then you will need to install the version Jazzy of ROS2. Either ways, the code that we will be developing during this course is compatible with both of them. In this lesson, I'm going to install the version Humble of ROS2, as now I am on Ubuntu 22, and also you can find all the commands that I'm going to use in this lesson in a PDF attached to this lesson. The installation procedure of ROS2 is very simple, and you simply need to copy-paste all the commands that you can find here at this link that you can also find in the resources of this lesson. So here actually all of these are the commands that we need to use. So let's open a new terminal. Let's place on this side, and now let's start copy-pasting simply all the commands that we have here. So let's start with the setting of the local. So let's copy this command here. Actually, we can ignore the first one, as this one only checks for the UTF-8. Now let's also copy this second command. Perfect. And so let's continue like this. So let's copy also this command and also the last one for this section. Perfect. Now let's move on to the next section that instead is about setting up the sources. So let's start with the first command as always. Let's paste it. Then the second command. Perfect. So let's press enter. Now let's move on to the installation of car. So let's copy this one and let's paste it. Okay, and now we can use car, so this one here, in order to download and set the ROS2 keys. Perfect. So we are here, so we can copy also this command here, and we can paste it. And so now we have set up everything, so we are ready to install finally the ROS2 packages. So first, we need to update our system. So let's update it. Then we also need to upgrade it. So let's take this one and let's paste it. Perfect. And now we can finally install ROS2 Humble. So here we can install the recommended version, that is the desktop version, that already contains some very useful packages, such as, for example, RVs. It contains also some demos and some tutorials that we're going to use during this course. So let's copy this command and let's paste it. So this will install a lot of packages, as you can see. So let's wait for the installation of ROS2 to complete. Once the installation of ROS2, the Humble desktop version, so this one here, is completed, we can move on to install also this one here. So this is very important, so let's copy this command here and let's paste it. As with this command, we are installing the ROS developer tools. So this one here, and as we are becoming ROS developers, we are going to need many of the tools that are here within this package. Perfect. And as the last step, we can see here for the installation is the environmental setup. So actually we need to set up our ROS2 installation. So as you can see here, our ROS2 is being installed within this directory here. So in opt ROS Humble. And so actually we can just copy this command here. And in order to automatically source the ROS2 installation every time we open a new terminal, we can insert this line here within a file that is called bashrc. So if in fact we get the list of all the files that are now in the home directory, we can see that it exists a file that is called bashrc. So let's modify this file, for example, with nano. So let's modify it, the bashrc, and actually we can go at the end of this file. Perfect. So here we just need to paste this command here, so the one that we have just copied. So now let's press Ctrl O in order to save these changes. So let's press enter and then Ctrl X simply in order to exit. Perfect. So now if we open a new terminal, we should be able to use the ROS2 command. And so if we use, for example, the flag -L, perfect. So now we have the confirmation that actually the ROS2 is correctly installed in our PC. And also we can see that this command here returned a very long list of commands. So all of these are ROS2 commands. So as you can see here, and don't worry if for the moment you don't know this command yet, or you don't understand the output of this command, as we are going to use many of these commands here. So we are going to use many of these ROS2 tools in the following lessons. In this lesson, I will guide you step by step in setting up the development environment. This is a fundamental step, as using a good code editor that has properly been configured for our needs not only helps us to develop our code faster, but also to detect the errors in advance and also provide guidance on how to resolve them. During this course, I will be using Visual Studio Code to develop the code, and you will soon understand why this is the best choice for developing applications with ROS2. There are in fact countless plugins that you can install in order to configure and customize your development environment, offering various functionalities. So let's start to install Visual Studio Code by opening the Ubuntu App Center, so this one here that you find on your Ubuntu installation, and let's just look for code, and here we can see it. So let's open and let's install Visual Studio Code. Perfect. So now it is installing Visual Studio Code on our Ubuntu machine. Once the installation is completed, we can finally open Visual Studio Code. So here we go. And now, apart from selecting the theme that you prefer, we can install some extensions that are going to help us during the development of the code. So the first one that we're going to need is the C++ extension. So this one here. And also we're going to need this one here, so the extension pack. Then we also are going to need the CMake extension. So as you can see, this is already being installed because we have installed the C++ extension. Then let's also have the Python one. Perfect. So this one here is enough. And then we can also install the XML extension. So this one here, and also the XML tools is very useful because it will auto-compile some XML files. And then finally, another very useful extension, and probably the one that makes Visual Studio Code the best code editor for working with ROS, is the ROS extension directly developed by Microsoft. So let's install it. Perfect. So now we have all our extensions. So all the extensions that we need, we have all of them installed in our PC. And soon you're going to see how all of these extensions are going to help us when we develop the code. So with this, the configuration of Visual Studio Code is completed, and during the course, we will see how to use and how to take advantage of the features offered by all of the extensions that we have downloaded in order to develop our application faster, with fewer errors and with more ease. Now, after installing and configuring Visual Studio Code, since we will be using the Linux terminal quite extensively during this course, I recommend you installing a more advanced version of the normal Ubuntu terminal that is called Terminator. So actually, you can see that this one here is Terminator that I'm going to use along the course, and instead here you have that this one is the normal standard Ubuntu terminal. So in order to install this one, so that is Terminator, and to use this one, you can use the command sudo apt-get install Terminator. So in my case, perfect. In my case, I already have this package, so it's already at the newest version. Perfect. And so we are going to use this terminal because it offers some functionalities, like for example, the possibility to open terminal in the same window. So here, these are two different terminals, and I can also open terminals as I prefer. So for example, with Ctrl-Shift-E, I can open another terminal on the side, and with Ctrl-Shift-O, I can open another terminal at the bottom. Also, I can press Ctrl-Shift-W in order to close one terminal, or also I can press Ctrl-Shift-X to make one section of the terminal bigger, and now in order to go back, again, Ctrl-Shift-X, and we are back to the original configuration. Perfect. So these are just a few tips in order to get started with Terminator. Now, actually, let's close all of these. Let's just use one single terminal in order to proceed with the installation of some ROS2 packages that we're going to use during this course. So in order to install any ROS2 package that is available in open source, we can just use the command sudo apt-get installed, followed by ROS, followed by the ROS2 version that we are using. So in my case, as I am on Ubuntu 24, it is Jassy. And then let's start by installing the ROS2 control library. So let's press enter. Perfect. So this is going to install the ROS2 control library, a library that we are going to use intensively in order to move the wheels of our robot. Then let's also install another library that instead is called ROS2 controllers. So let's press enter, and let's also install this library. Then let's install one more library that is called Xacro. So again, ROS, Jassy, and then followed by Xacro. And then also I'm going to install the ROS Gazebo. That is the simulator that we're going to use in the course in order to simulate our robot. And so in order to start working with the robot, also if you don't have built the real robot, so let's install it. And this is quite a huge installation. Then let's continue with the installation of another package. So again, ROS Jassy, as I am on Jassy. And here remember that, for example, if you are on ROS Humble, so you need to use ROS Humble like this if you're using a different version. So now I am on ROS Jassy, and I want to install all the ROS2 control plugins. So all the ROS2 control plugins for Gazebo. So let's press enter. Here is ROS2 control. Perfect. And so now you can see that I'm going to install this one here. So this is the one that we are looking for, the Gazebo ROS2 control plugin, in order to use the ROS2 control package with Gazebo. Then let's also install another package that is called Joint State Publisher. And I want the GUI, so the graphical user interface. Perfect. And also this will install the Joint State Publisher. So this is installing both the Joint State Publisher and the Joint State Publisher GUI. Then let's install another package that is called TurtleSim, and actually this is so here it's TurtleSim. Perfect. So let's install it. This is already installed, and this is a pretty funny package that we're going to use to develop some examples and to test our code. Then let's also install the robot localization package. So let's press enter, and actually this package, as the name says, will help us in the robot localization. And then let's install other packages that are the Joy package. So here is ROS Jassy Joy. Perfect. And also need the Joy Teleop. Perfect. So let's install also this package here, and we're going to use these two packages, so the Joy and the Joy Teleop, in order to interface and in order to move our robot using a joystick. So then let's also install another package that is called TF Transformations with the final S. So let's press enter. Perfect. And these are actually all the ROS2 packages that we need for the moment. Now let's also install some Python packages. So first, let's make sure that you have pip installed on your PC with sudo apt-get install, and let's install Python 3 pip. Perfect. So in my case, I didn't have this package installed, so it is installing it. And now we can use pip, that is the Python package manager. So with pip, in order to install another package that we are going to need just for the Python classes, that is the transforms 3D package. So let's press enter. If this is not working, so if using a pip is not installing the transforms 3D package, we can use also the command sudo apt install Python 3 transforms 3D. So let's press enter, and actually this is correctly installing this package here, so the transforms 3D package. And this is actually all we need for the configuration of our development environment, and we are ready to develop the code for our amazing robot. In this lesson, I will guide you step by step in setting up the development environment for Ubuntu 22. This is a fundamental step, as using a good code editor that has properly been configured for our needs not only helps us to develop the code faster, but also to detect the errors in advance, and also provides guidance on how to resolve them. During this course, I will be using Visual Studio Code to develop all the code, and you will soon understand why this is the best choice for developing application with ROS2. There are in fact countless plugins that you can install in order to configure and customize your development environment, offering various different functionalities, from code auto-completion that is available in almost every programming language, also to the customization of icons, comments, and most importantly, one thing that we will rely on this course is the support of ROS2. So let's start the configuration of this code editor, and simply in order to install it, we can open the Ubuntu software, so this one here that comes with the Ubuntu 22 installation, and we will simply look for code. Perfect, and so let's go down here, and we will need to install this one here, so Visual Studio Code, as you can see here. So let's install it, and now let's wait for the installation of Visual Studio Code. Once it is installed, we have it in the list of the applications, so let's open it. And here we go. So this is the main page of Visual Studio Code. And here, apart from choosing your theme, the most important thing that we need to do is to install some extensions that are going to be very helpful in the development of the code. Let's start with the C++ extension. So this one here, let's install it. And also let's install this one here, so the extension pack. Perfect. Then let's also install the Python extension. Perfect. So this one here for the support to the Python language. And then we also can install the CMake extension, and these one here are already being installed. So since we have installed the C++ extension, these are installed along with it. So perfect. Let's also install the XML extension, this one here, and also the XML tools. Perfect. So this will provide us the auto-completion for the XML files. And now let's move on also with the installation of the most important extension that we are going to use in this course, that is the ROS extension. So this one here that is directly developed and supported by Microsoft. So let's install it. Perfect. So with this, the configuration of Visual Studio Code is completed, and during the course, we will see how to use and how to take advantage of the features offered by all these extensions that we have just downloaded, and that will help us to develop application faster, with fewer errors and with more ease. Now, after installing Visual Studio Code, so we can close it since we have all the extensions that we need, let's move on to install other useful components. So since we will be using the Linux terminal quite extensively in this course, so this guy here, I recommend you installing a more advanced version of the standard Ubuntu terminal, that is this one here, and is called Terminator. So as you can see here, I have the normal Ubuntu terminal, that is this one here, and here I have Terminator. And the cool thing about these different terminals, so basically they are the same, and you can do the same things, but the cool thing about Terminator is that you can open more windows, so you can open several different terminals within the same window. So here, as you can see, this has a better management of the windows, and also, for example, here with Ctrl-Shift-A, we can open a new window on the side, and with Ctrl-Shift-O, we can open a new window in the bottom. Also, we can close existing windows with Ctrl-Shift-W. Perfect. So we have closed the window here in the bottom. And for example, if we write something and we press Ctrl-Shift-X, here we have made this terminal bigger, so we can see this command better. And in order to go back to the previous configuration, we can press again Ctrl-Shift-X. And so we are back with all our terminals. So this is just a better management of this terminal. So if you want to install it, you simply need to use sudo apt-get install Terminator. So in my case, I already have this one, so I already have the newest version. And so actually, whenever I open a new terminal, automatically I have Terminator. Perfect. So now that we have Terminator, we can also move on to install some ROS2 packages. In order to install any ROS2 package that is available open source, we can simply use the command sudo apt-get install with ROS Humble, so the version of ROS2 that we are using, that in this case, as we are on Ubuntu 22, is ROS2 Humble. And for example, if you were on Ubuntu 24, the version is called Jassy, so this one here. Now, let's use ROS2 Humble, as we are on Ubuntu 22 now. And let's start by installing a package that is called ROS2 Control. So we're going to use this package, the ROS2 Control package, quite intensively. Okay, now the password is correct. As I said, we are going to use this package, the ROS2 Control package, quite intensively, as it will be at the basis of the movement of the wheels of our robot. Then let's also install the ROS2 Controllers package. So let's press Enter and let's install this package. Then let's install the ROS2 Humble Xacro package. Perfect. We can also install Gazebo now. That is the software that we're going to use in order to simulate our robot in our PC. So let's install the package that is called ROS Gazebo, and let's install all of the packages that are here. So as you can see, this will automatically look for all the correspondence and will install all these packages. So it will overall install Gazebo. That is, as I said, a software for simulating our robot that we are going to use in order to test our software before moving on to the real robot. Once the installation of Gazebo is completed, we can move on with the installation of another package, and this is the Gazebo plugin for the ROS2 Control. So let's install everything under the name ROS2 Control. So let's press Enter, and actually, among all the other packages, this will install this package here. So the Ignition, that is the name of the Gazebo version that we are using on ROS2 Humble, ROS2 Control plugin. So let's press Yes, and let's press Enter, and now let's wait for the installation of this package as well. Then let's continue installing another package that is called Joint State Publisher GUI. So GUI stands for Graphical User Interface. And also let's install the ROS Humble Turtle Sim. So let's press Enter. This is already installed, and this is a package that contains a nice graphical interface with a turtle that we can use to test our code. Then let's also install the ROS Humble Robot Localization package. So let's press Enter, let's type the letter Y, and let's press Enter again. And as the name of this package suggests, this will help us, so this will provide some useful functions, some useful software in order to help us with the robot localization. Perfect. Now let's also install the ROS Humble Joy package, and also the Joy Teleop package. So let's press Enter, and as the name of these two packages suggests, so the Joy and the Joy Teleop, this will allow us to connect a joystick to ROS2 and to use it to move our robot. Then let's also install the package TF Transformations. Perfect. And this is actually the last ROS2 package that we need for this lesson. Now we can also install some other Python packages that we are going to install only when we are going to develop some Python code. So let's start by installing pip, so the Python package manager, with sudo apt-get install, and let's install the Python 3 pip. Perfect. And now we can use pip in order to install a package that is called Transforms 3D. Okay, so actually this package is already installed in my PC. And that's it. With this, we have configured our development environment, and so we are ready to develop the code for our amazing robot. All the code we will develop in this course is available on GitHub using the link provided in the resources of this lesson. This repository, as you can see, is organized by section, and you will always have here access to the most up-to-date, functional and tested version of all the nodes and features that are developed in the course. You can use this material as a starting point to follow the laboratory lesson, and also as a template to develop new features. For instance, let's say that you are following the laboratory lesson in the section 3, so let's say that you are here, and that you are following a laboratory lesson with Python, so that are developing in the BumperBot by example. Let's say that you are developing here, this one here, the simple publisher node. So here you have all the code that you're going to write in the laboratory lesson, and you can just use this code. So you can just copy-paste this code so that in the laboratory lesson you just focus on the concept that I will explain. Or also, if you prefer, rewrite the code from the laboratory lesson yourself, so you can just use this code here just as a reference, so in order to check any bugs or typos in your code. Now, let me show you how you can use this material in order to debug, so in order to spot any error in your code. Let's say, so here in Visual Studio Code, let's say that you are developing here the simple subscriber node. And so let's say that you have written all this code on your own following the lesson. And then when you try running it, so when you try executing it, so basically you open a terminal, you go to your workspace, you properly build it, and also you properly source it. So now let's wait for the build, then let's source it with the setup.bash. So let's source this file here, and then you run it. So with ROS2 run, let's say that you run from the BumperBot by examples package the simple subscriber, you press enter, and this throws an error. So here we can see that when we tried to start our executable, so when we tried to start the node that we developed, so here we can see that we have an error, even though everything works perfectly in the course lesson. Classic, right? It always runs smoothly in the video, but never on your PC. I know the feeling. In this case, as a first step, I recommend you carefully reading the error message that is printed in the terminal. Normally, this provides a lot of information that you can use to solve the problem on your own, and perhaps it's even going to highlight the line which is affected by the error. You can also try to revisit the laboratory lesson to spot any typos in your code. While debugging can be challenging and even frustrating, it's an invaluable part of the learning process. It encourages you to understand each line of code more deeply, and this is a skill that you will rely on in all your robotics projects. I would suggest you to start by searching the error on Google. So let's copy the error message, so this one here, and then on Google, let's try to get more information about these errors. And so here, normally there are a lot of resources that can help you in order to understand the error and also in order to fix it. So we can see very often Stack Overflow, ROSWiki, so ROS Answers. We also have Robotic Stack Exchange. So these are all very useful resources which we can rely on in order to fix our issues. And also these, so ROSWiki, Robotic Stack Exchange, and also Stack Overflow are also an excellent examples of communities where developers of all levels and backgrounds can collaborate to solve problems. If this step didn't solve your issue, you can also try to use ChatGPT. And so here, try to be as descriptive as possible. And also let's try to copy some code snippet that is causing this issue. Like for example, let's copy the entire code, so the entire node. And here we can ask to ChatGPT, this code is causing the following error. Like this, and then let's simply paste also the error that we have. So this one here. Now let's copy and let's paste the error. So let's try to be as descriptive as possible. And this is an amazing tool because most probably not only is going to fix the issue, so not only is going to suggest you a possible solution to the problem that you are having, but is also going to explain in detail which is the problem, so where is the problem and why this occurred. And so this can further enhance your understanding of the topic. If also after this step you are still stuck on your problem, let me show you another debugging strategy that is comparing your code, so basically this code here that you created in your Bumperbot workspace, so this one here on your PC, so to compare this one with this one here, so with the code that I uploaded here on GitHub. Now let's say that for example, so here we want to clone this code here, and so this one here, let's go to local, let's copy this address here, and so now we can use in order to clone, that is to download this code here, so the one that I uploaded on GitHub on your PC. So to do so, we can open a terminal, and here in the terminal, we can use git clone, and then we can paste the address, so this one here, to the GitHub repository. So let's clone it, and basically now this command is downloading all this code here, so all of these packages here. Perfect. So now the only thing that we need here, so let's say that this one here is the code that we have just downloaded, so the code that I uploaded here on GitHub, and this one here, let's say that this is your workspace, so the one that you are working on and on which you are developing new code. So now in order to compare this code here, that is the one that you have written, with this one here, that is the one that I uploaded and I can guarantee that always works, so this one here, we can simply use again git. So basically we can go to your workspace, so this is where you have your code, and here we can use the command git init. Perfect. So with this one here, we are initializing git in this repository. Then we can use git add dot in order to add all the files. So all the code that you have here in your Bumperbot workspace, we are adding it to git. Perfect. And then we can also use the command git commit. So this is going to create a fake checkpoint. So let's call it, actually, so let's give it a name. And let's call it checkpoint. Perfect. And so we can see that we are adding to this checkpoint all the files that we have in our workspace. And now, in order to compare, so this one here that we have just committed, so that for which we have just created a checkpoint, so in order to compare it with the code that I publish here on GitHub, so we can simply open this folder here, so the folder that we have cloned. Now we can go to the section that you are following. Let's say that you are following the section 3. So this is the Bumperbot workspace for the section 3. And so for the Bumperbot workspace, actually we just can copy the content of the source folder. So these two packages here, so let's copy them. And now we can go to your workspace, so to the Bumperbot workspace, to the source folder, and we can remove the packages that you were using, and you can simply paste the packages that I uploaded here. Actually, this can seem like just copy-pasting, so just copy-pasting my code into your workspace, but actually this is going to provide you a lot of insights. And in fact, having used Git, we can use in Visual Studio Code this tool here that is source control. So let's open it, and here this tool will actually highlight the changes between your code, so the one that you wrote, and my code, so the one that I uploaded on GitHub. And so here we can see that it's pretty straightforward to identify the issue and in general to identify any differences between the code that you are using and the code that I uploaded on GitHub.